So this is relationships through time. This is often really useful when we're thinking about, how to set prices next month. We want to particularly focus on the most recent data, and a line graph allows us to see what that data is. The most recent is more important, and so it allows us to sort of identify what's most important. But let's see, Sophia mentioned the possibility of seasonality. What if, in addition to the most recent data, what if there were trends that were consistent through time, but at different points in the calendar? It's a little bit hard to see that kind of thing from a figure like this. We've highlighted, some points of decline, so maybe there's you're able to see some patterns here. But in general, we can have subtrends, just like we're seeing, where we have periods of decline, subtrends within a larger trend. And sometimes those trends are specific to seasons. So what we're going to do next is talk about the possibility of seasonality. So maybe prices are higher or lower in different months. So you'll remember the familiar box and strip plot. We just have the horizontal axis with coffee prices, and then we summarize the quartiles using a box. This makes it very easy to read some of the main components of the distribution just very easily with our box plot. So you'll remember the bottom whisker is just the minimum, the middle part of the box is the median, and then the upper whisker is the maximum. And so on top of the box plot, I often like to include this strip plot. But I'm actually going to take out the strip plot and show us just all of the months all at once. So this is what we call a multi-boxplot. So we have box plots showing the distribution of prices across different months. So it's in January, we're just going to look at all of the prices that happened in January and show the distribution just in January. And then in February, we're going to show just the distribution in February. So we've essentially taken out the sequence, right? So it's no longer in sequence through time. But what we've done is break out the seasons and show the distributions within each one of the seasons. And this gives us another perspective on the data. Sometimes the seasonality will be much more clear. But even with a data set like this, where we go back all the way to 1973, we can still see some patterns. So if I were to ask you, we've just looked at the overall trend. Are there subtrends? Like, is there some seasonal component to prices? If you're looking at this, what might you say? Yeah.
Not really.
Yeah, it doesn't look like there's a whole lot of seasonal variability here. What else? There might be a little bit. So let's maybe look at a few things just to see maybe some sub-patterns. But I think the general pattern, remind me of your name? Luke.
Yeah.
So Luke, I think Luke's general conclusion here is pretty sound. When we're simply looking at measure of average, I think there's very little variability. And we're gonna zoom in on this a little bit later. Very little variability by season. Not a lot of seasonal pattern to prices. But I want to be a little more specific before we get there. So let's ask maybe some sub-questions. In which month was the highest price recorded? Yeah, lots of hands. Yeah. April. And why are we saying April?
Because that's where kind of the maximum is for the
Nice. So we're looking at we're able to see this because we have box plots. We look at the upper whisker across all of the months, and we can see that April has the highest upper whisker, so April has the highest maximum price. Remind me of your name?
I'm Kyle.
Kyle. So Kyle is using the fact that box plots visualize the quartiles to be able to answer this kind of question. Any questions here? What about this question? What season are prices most spread out? Yeah.
Probably like spring, like March, April, May.
Okay. And how are we noticing that spring has the most variability?
So like maximum.
Yeah, nice. So maybe we look at ranges, and then we try to find which general season has the largest difference between the upper and lower whisker. Remind me of your name?
Jason.
Second time I asked you for your name, I guess. So you can quiz me on your names. I think I'm not getting a passing grade at the moment. So Jason's saying we're going to look at the ranges, and then we identify which range or which general season has the largest range. And I would say generally that's like spring. Yeah. Any questions here? So this multi-boxplot gives us some extra information about the possibility of seasonal variability. Like, are there patterns by season? What about this question? Which I think goes back potentially to Luke's earlier observation. Is there a trend here? Yeah, Alexis.
It's like around $1.25 a cup.
Yeah, pretty stable. So the middle price through time seems to be pretty consistent. It's a little bit hard to see here, but one thing we could do is take each of the quartiles. So I'm going to take each of the lower whiskers, the median, and then the maximum. I'm going to ignore the Q1 and Q3, and then just plot these three, the minimum, median, and maximum, as line graphs. So I have 3 lines, minimum, median, and maximum, which allows us to see sort of the time variability of these quartiles. So is there variability through time in this way? And I think this is maybe another picture that allows us to see. I mean, first off, the maximums seem to all happen in the spring. And then you can also see minimum and median just don't seem to change that much. They seem to be very flat, at least on this scale. But one thing we can do here is zoom in even further. So if we change the vertical axis scale and we just plot the medians, you can ask maybe more subtle questions. It doesn't seem like there's a lot of variability here. But one thing we could do is just ask this kind of question. So maybe take a second here, like 15 seconds to find like a general number for this question. We're looking for the difference between the largest and the smallest medium price per pound. Anyone have a number? Yeah. Around 0.1. Yeah, something like that. So you can see the minimum, and maybe I didn't do a good job of labeling this, but this is like maybe 1.21, and then maybe the upper is around here, so maybe 1.0, 1.30, which I'd say maybe a little closer to 0.09, but yeah, generally right around 0.1. Yeah, very nice. Remind me of your name?
James.
James. If you quiz me on your names at the moment, I'm sorry to say I'd really struggle. Thanks for the answer, James. Okay. Any questions about this? So what we've done, right, we have the basic line graph, which gives us the general sense through time, gives us longer term trends. But sometimes we care about sub-periods within a longer time series. And so one thing we can do, just as we've done here, is try to pull out seasonal variation by looking at months. And we can do that pretty easily using multi-boxplots. Sometimes, like with the medians, the variability in the median itself is not very large. And so to zoom in on that specific quartile, one thing we could do is just plot those quartiles directly as a line graph. And that gives us maybe a more subtle perspective on the variability of a statistical measure through time. Okay, so depending on your question, if you were wondering what's the difference between the median and the minimum and maximum median across months, this is how you would maybe try to answer that question. It'd be difficult with a line graph, and it would be difficult just looking at the box plots themselves. So, as always, one of the big conclusions here is that we want to match the visualization tool to the question and the data. So what's the question we're trying to ask of the data? Let's use the right visualization tool for our purposes. All right, any questions before we jump into this? So the last thing we're doing today is constructing a multi-period box plot. And we're gonna do this with both Excel and Python. So this is just a bit of that summary I just mentioned. Line graph is good for numerical variables through time. We can highlight sub intervals using shading, and then we can use the multi-period box plot to show the distribution. So let's jump back to the coffee prices data set, which unfortunately I closed, but we can open this back up. Actually, for the sake of time, we can do this in Python. There's another step we have to do. I'm sorry, in Excel. But what I want to do is, for the sake of time, let's do this in Python, and then I'll explain how we do it in Excel a little bit later. Okay, so we have our data set up here, which is just prices. And then what we want on the, right, we want the, you can do this in a couple of ways. The vertical axis, the way I have it set up in the slides, is with month on the vertical axis. And then the distribution within the box plot is on the horizontal axis. But I'll show you, we can do this either way. We can sort of flip it so the boxes are oriented vertically if we prefer. As you'd expect, this is pretty simple to do. So if we're thinking about how to construct Seaborne figures, the place we start is just S and S. And then we want a box plot. It's a multi-box plot, but we just write it as box plot by default. So this is box plot. We have prices, and then I want my preference is to put the categories on the vertical axis. So I'm going to use Y for month, and then I'm I'm going to use x for price. So my x variable, the horizontal axis, is price, and then the vertical axis is a month. And when I do that, I get a figure that looks like this. I don't like having outliers in the data. What I like to do is include all of the data points in the distribution itself. I think it's a little bit funny that by default there are outliers. In general, we like to include all of the data points, at least by default, within our distribution. It's part of the distribution, and so we want to describe it that way. So what I'm going to do is specify that I want the whiskers to contain every data point from the 0th quartile, percentile, all the way up to the 100th. So I'm going to say whiskers, and then we want the range from 0 to 100. And when I run this gives us the box plot that we were hoping for. Okay, any questions here? So we can do this also in Excel. And I think let me just talk through how we do this. We don't have a month. We can construct a month from the year. This is a little more challenging to do in Excel. So this is going to take a little bit longer than we have class time for, but let me show you how we would do it if we had a month column. So if you had month, and then we had, like this is August, and then September. If we had that column, Excel actually has a built-in box plot feature. And maybe I'll fix this and bring it into class next time. But you go into statistical, and then there's a built-in box and whisker plot that actually gives you multiple box plots, and you can use that by category. But unfortunately, it looks like I didn't include the month here, so we'll have to do that next time. Okay, how many of you were able to create the multi-box plot? Okay, and if you weren't able to, now's a good chance to check with someone next to you about how to do that in your own code. All right. So before we go, can I get a poll? How many of you think creating figures is easier in Python? And how many of you think creating figures is easier in Excel? Yeah, we don't have to agree. But I agree with most of you. I think visualizing data sets is much simpler in Seaborne, in Python, than it is in Excel. What we've done today is focus on relationships through time. We've talked about the general trends that we can see using time series. We don't typically summarize time series variables using a histogram because we care about the sequence. We want to know where in the sequence each data point is. Then we also care about subtrends. And so one way we can visualize subtrends is using shading, but the main tool is using multi-box plots. This is time series. This adds another dimension of variability to our data. Next time, we're going to talk about variability across individuals and through time. So we're going to talk about panel data by looking at, can you guess, coffee? Okay, that was supposed to be funny. I'm going to have to work on my jokes for next time. Stick around if you have questions about the homework. Homework 1.3 is posted, and 1.4 will be posted pretty soon.